Have a different application for entry and exit mode. Now, if we look at entry and exit mode, up till now we've been using entry and exit mode to get into an operation and get out of an operation. But an entry and exit mode can also be used as a transition from one operation to the next operation. So when I'm done with this operation, I can make it pull down to a diameter that's outside of this area. Put my cursor down here, I see that number is about 660. So if I drop down to about 650, something like that, I might drop in where it says exit mode and say, let's go to X only of a value of 0.65 or 16.5 millimeters. So we go about 16.5 millimeters down. Now what that does, if I hit OK, that's going to create a point right there. So when the operation is finished, it's going to wrap it to here. And then what we do is on the next operation, we jump in and change the entry mode to none. So it means it'll wrap it from that point over to start doing the next cut. And that'll start creating the next operation. Now while we're in this operation, let's now talk about some other little changes we might want to make in here. First, we go into the rough page. We might want to bump up our step over. Now we're only going half the cutter. We might want to go a wider step over because we've got a small radius on the tool. We could go something like 75%. That'll reduce the number of passes in here. Now the next thing we have is, let's talk now about some of these plunges. Now right now we're doing what's called consecutive plunges, but we could alternate the plunges, alternate adjacent, across, etc. We'll talk about that in a minute. The one I want to change next is actually the plunge direction. Right now it's going forward, which means it goes from the feature. It looks at the feature. Forward means it goes relative to the feature, so it's going to start here and go this way. We can also go center in both directions. We're going to try that one. And then below that we have a setting called peck increment. And if we plug in a value, let's say I want to peck a value of say 0.120 or 3 millimeters, and I hit my tab key, you'll see that below that we now have some new settings. We have what's called a peck order. Under peck order, we can either peck down, then across, or across, then down. Care of that cut. Now one more thing I want to add here. I want to make absolutely certain that we haven't violated our solid at all, our part. So one of the things I'm going to do is I'm going to add a component to simulation that I don't think we've added yet. And under simulation, since we defined a solid for our stock, I'm going to go ahead and add a target. Now a target is something that you can add if you have solids here. Now if you're working off of simply the bar stock or tubing from machine setup, you can't add a target to that. But I'm going to add a target from a solid. I'm going to change the color. I'll make it some other bright color. So if this tolerance in this setting here of 0.1001, I'm going to leave that as it is because this is a fairly small part. If this was a bigger, more complex part, I might want to bump this number up a little bit. Not much. This number you want to keep fairly small. So now I'll hit the select feature and pick my solid model and say yes, and I'll hit add and I'll have a target, and I'll hit OK. Now under the target, there's a visibility box right here called target visibility that allows us to go ahead and run a simulation, and you'll now see underneath the actual solid, you'll see, I'll unslice that here, you'll see the part superimposed onto the stock. So you can clearly see where there's some excess material in here. So you can come in and see how we're going to be removing our stock on the face. And we would have collision detection if we were to run into the part or the solid at all. And you see where we're blending into where the target was. Because there's all this material still left in this part. If I did a final state right now, you'll see we've got all this material to remove. So I'm going to go ahead and pick the feature, and I'll go into my my solid turn, and I'm going to go ahead and tell it to do a roughing operation. And I'll tell it to use my V&MG left side. That's a tool we define with a 3V orientation to go in the left side. And we adjust our feeds and speeds to whatever works for you. And under strategy, we're going to tell it that this is going to end up being a Is it going to be an OD or a face? Well, the predominant motion is going down along a face, so I'm going to tell it to do it as a face. And I really don't need a finish pass. And I probably don't need much in the way of starting in extensions. There's not a lot of room to work. Okay? And the key setting I do need to make sure is I need to tell it undercutting is yes, because I have to be able to undercut in here. Got to be able to undercut. Okay, next page, rough. And how do I want to define the stock? Well, I'll use automation, and let's tell it to leave a little bit of stock for a cleanup. Now, there's not a lot of room in here, so I'm going to tell it to leave about 2 thousandths in X and Z. Now, parallel to axis is going to try to cut it going vertically up and down this way. That's really not going to work well. I think this is a case where we want to utilize offset. And under offset, we want to set in a pretty small amount. There's not a lot of room to work in here. I'm going to put in about 10 or 15 thousandths. I'll go 0.015 for this. And then as far as clearance along cut, we don't have a lot of room to work here either. So I'm going to set this down pretty small, maybe 0.05 for both of these values. So I'm setting those two values down a little bit smaller. And then we go down to our lead in, lead outs. I think tangent for both, for the in would work well. Tangent lead in, not much, maybe 0.05. And then I think just a simple vertical normal. When it gets done, come normal this way. And again, don't need much, maybe 0.02. And let's hit OK. Which goes down the angle, goes all the way down to here. Now what we're going to do is we're going to use that feature to do the cutoff. So we're going to go up now to a solid turn and do a cutoff operation. Now we've not done a cutoff yet, so we go to the tool, we choose the cutoff tool, we drop down, and we identify the RPM or surface footage. If you want to run surface footage, you can. If you want to rather run RPM, that's up to you. So I'll say RPM, and I'll do RPM here. I'll change my feed rate, and I'll jump over to the strategy page. Now, we're going to do a rough pass and a finish pass, because we actually do want to finish this, because we don't want to do this on a secondary operation. So we're going to say yes to yes. Entry and exit mode, I'll leave the entry mode alone. Exit mode, when I get done, I might want to wrap it back up to the OD. So I'm going to say exit mode X only, and plug in a number bigger than the radius of the stock. The stock's 2-inch material, so I'll go up, I'll say 1.2, which will get me up to 2.4 diameter. Always remember, when you see the letter X, it's radial. It's a radial number. Now, do we want to use a parts catcher, yes or no? I'm going to say yes. I'll just use a parts catcher in this case. Next, we jump over to the rough page. Now, on the rough page, it's asking us how's the stock defined. And we'll say the stock is defined as automation, so it automatically sees the stock. Now, we want to do a rough stock allowance. We want to leave a little bit of stock for cleanup. I'll tell it to leave 5 thousandths. Now, we get to the rough diameter, and what it wants to know here is how far do you want to rough it down to. Now, you might think you'd go all the way down to here, but all you really need to do with the rough is get past this chamfer, because when you rough this, it'll make a little rough pass down slightly past the chamfer, back up, scoot over, and then cut the chamfer and the cutoff all in one motion. So I'm going to click the arrow and pick just a little bit below this diameter. If you want to type in a hard number, you're welcome to. I mean, it's just a number to go down to. And then the stock clearance means how far you want to clear your stock, if you want dwell. And then also it wants to know if you want to do any pecking. You can do pecking with your groove. Now let's go to the finish page. How much stock for the finish pass? Well, 0. So, and then the RPM, I'll plug this in. I can make a different feed for the finish. And then now you've got a lead in and a lead out. So I'll say lead in. I'll make it to be, let's say I want it to be tangent. Tangent. And give it about 50 thousandths. And lead out, I'll start with none. And just hit OK. And that should now do this, and the rest of the stock should now disappear. I'm going to make a little change here. I'm going to change this guy, and what I want to change is the tool motion pattern. Instead of using a traditional concentric pattern, I'm going to now use profit milling. Now when I change to profit milling, you see a bunch of these options here. Matter of fact, all of these options right here below this will all disappear. Okay, and now we have the options of stock allowance and depth. In fact, on depth, what I'm going to change is if I'm doing profit milling profit milling is really designed to cut full depth. It's really designed to go as deep as that tool can go, and then but we're going to control how much of that tool is cutting with the side of the tool. And so I'm going to tell it, I'm going to go here and change this incremental depth to 0. I'm also going to go back to my general page, and I'm going to make some changes to feeds and speeds. I'm going to change this now to about 10,000 RPM, and I'm going to change this feed rate to about 200 inches a minute, and I'll change the Z feed rate again to 25, maybe I'll leave it on at 25 to don't scare anybody. Constant removal rate, I'll just turn that to no, because profit milling can do all of its own adjustments for feeds and speeds as well as when it cuts the part. Now back to the strategy page. Everything I've set the way I want it. Pocket page, I still have the same settings for open edges. But now on the rough page, the big thing I want to change here is this step over. This is how far it's going to step over. Now obviously I'm going much deeper. I'm going, instead of a 1/4 inch, I'm going 600 thousandths deep in the part, actually 400 thousandths deep. And then what we determine here is a step over as either percentage of the tool or a physical value. A good rule of thumb here in profit milling is anywhere between 5% and 10%. It's a pretty good, safe number. Now, we're not going terribly deep here. I'm going to go about 8% here. When I hit my tab key, it'll plug in what 8% of step over is. So it's only going to cut 20 thousandths on the wall at each cut. Now entry mode, we still have the same choices, but I'm going to do a plunge here. And then exit mode, I'm going to do a feed over, wrap it up. So we have a different choice here on exit mode. Now wall finish, I'm going to leave the same. Same tool, same feeds and speeds, same depths of cut. Nothing's changing here, and nothing's changing on the links. All we're really changing is we've added profit milling, and we've adjusted the depth of cut, the feeds and speeds for roughing, and we've also adjusted the step over. And we hit OK. And that is by using an add-in. Underneath Tools, Add-ins, there's an add-in called Soft Sync Add-in. I'm going to turn that add-in on. And of course you would want to turn on load on startup so you make sure that it happens all the time. Now what this does is, you see nothing really happened unless I go into my my common machining toolbar. If I go in and pick on common machining, you'll see there are 3 new icons that pop up out to the right. The first one is add a sync, remove a sync, and remove all syncs. Right now, the way this add a sync works is if I pick it right now, I'm going to get a warning that says you need at least 2 operations. Right? Now this is similar to these 2 icons in that you're going to pick operations, not tool changes, but it's not as limited as these 2 icons. For example, if I grab this face and I now pick on the center drill over here, okay, so I have 2 items. And by the way, one of the things that's a little different too is that I, in this case, did not hold down my control key. I simply picked this face and I scoot over and I pick on this center drill. You'll see that the group count changed to 2. That's because I didn't have to use a control key. It looks at each column as independent. I would only use my control key if I was picking multiples within each of those columns. So in this case, I have both of these operations grouped. Now, when I go up to pick on this add sync code, you'll get a dialog box that pops up. And the first thing it shows you is it says the sync code. And it's going to, if you want to use sync strings, this is where you can choose them. And again, they must be identified first in machine setup. But now here's where all the action takes place. Under the upper turret, it says the operation. Of course, it's simply confirming the operation you already chose. But what it's asking you for is where do you want to place that? And the position can be one of 5 choices. This can happen before the tool change, after the tool change, before the operation, after the operation, and then during the operation. Now, the first 4 are the same 4 choices you have when you do it manually. And that's that subtle thing of doing it either before a tool change or after an operation. Again, very subtle, but it is something you can control manually. Here you can be very exact. You can say, I want this to happen, I want to say I want this to happen after the operation. Okay? And I want for the lower turret to happen before the tool change. So you see I'm forcing the sync to happen after this operation and before this tool change. When I hit OK, I get that sync show up. You see. So I know that features about 560 thousandths from the bottom all the way to the highest point. So now let's go in and let's create our operation to cut this out. So I'm going to grab my feature, got it grouped. I'm going to go into my solid MillTurn, and I'm going to, this time I'll use contouring. Instead of a pocket, I'll do contouring. Now, could I have made an open pocket there? Sure. I just don't see a real gain to doing that. I think a simple contour is plenty fine for a cut like this. So I'm going to use contouring. And under the general page, under the tool ID, I'm going to select the same 1/2 inch end mill. I'll plug in the same kinds of feeds and speeds. I'll go 15, and this time in Z I'll go a little deep faster because I'm clear of the part. I'm not trying to plunge here in this case because I have this material already removed. Strategy, what am I going to do here? One pass, fine. Do I want to finish pass? Nope, don't need to. Because I'm going to tell it to leave some stock. We're going to do the same thing we did on the pocket. We're going to leave 20 thousandths of stock. Now, as far as depth goes, I'm not going to do it all in one pass. I tell you what, let's do this about 300 thousandths depth of cut. And everything else looks fine. I'll move on now to my advanced page. Now, what that 300 thousandths means is I'll get a 300 thousandths depth of cut on the first cut, and then I'll get 260 thousandths or so for my next cut. So that's one way of making certain that. Now, if I wanted to make sure I had that same little, say small finish cut here, then I could look at, for example, maybe I want to take this in a couple of passes and leave, say, this 15 thousandths of stock. So if I wanted to go, let's say 550 thousandths, I could type in equals 0.55/2 and hit my tab key. That will give me 2 passes at 275 each, which will get me to 550, and it'll give me an additional 17 thousandths or so to clean up on the floor. Retract for eye depth, the surface clearance is fine. I might even just tell it just do a partial. We don't need a lot of clearance there. Advanced page, nothing to mention here of any note. The links page. On the links page, one of the things I want to make certain of is I've got clearance is fine for my return plane. The retract plane, I'll just tell it to do what's called a partial depth. So as it retracts from one cut to the other, it'll just barely back up off the cut. So it won't really do much depth-wise. And I'll even tell it to retract between the cuts as being none. Let's not do any retract between cuts. Alright, lead in, lead outs. I don't need a lot of room here. Let's go 50 thousandths. And then what I will do is I will overlap a little bit on the tool. So I'll let the tool overlap by about 10 or 15 thousandths, 10 or 15% of the cutter. Let's hit our OK button and let's see what we get. And what we end up with is a nice contour pass that goes around and cuts the part. Let's run a simulation on that. Now what's going to happen is that tool is going to index. It indexes to that 30 degrees, which happens to be the angle. Didn't know that till now. Now we know the angle. Now it's going down to the clearance. It's going to go in for the first cut, make a pass, position, feed down to the next level, make the next pass, and then one more pass down the next level to do a cleanup and retract. And now we've milled that area. Now we're going to take that whole feature and we're going to go in and we're going to drill it. We're going to go into drilling and we're going to select our number 32 long drill. And for depth, I'm going to go in and do a right-click System Default, so it gets the depth from the model. I'll do a no to this setting here. I'll change my full clearance to 0.1, which would be 100 thousandths above Z0 out here. And I'm going to change this to a peck cycle. I'll make it a fairly small peck. There's a reason for that, and I'll explain that in a moment. And let's hit our OK button, and that's going to now drill that hole. Now, one thing about that hole, let's go back to that operation one more time. That operation is actually happening on the sub-turret. So since it's on the sub-turret, it belongs to head number 2. So I need to make certain that I identify head 2 for that operation. Now when I do, that operation now shows up here. Now what we're going to do here is a little different, is we're going to go in and we're going to take that operation and we're going to go in and do it at the same time that we mill the 031 pocket right there. We're going to go in and actually do this pocket and this at the same time. So now what it's doing is notice it's trying to drill, but it's drilling and now trying to mill that pocket. And really that's probably not the best thing to do. What we really should have done is this drill right here. we might have rather have indexed it 90 degrees prior to drilling the hole. In other words, if I try to drill that hole right now as it stands, it's designed to be drilled setting up straight this way. But one of the things you can do with any operation that happens on the face of the part, any type of a live tooling operation, is you can actually go in and open up your rotary angles of the operation, and you can pivot C to any angle you wish. In this case, say 90 degrees. And what will happen there is when I run the simulation of that operation, it will automatically pivot 90 degrees to make that cut. So now I can run those two operations together, and they will fire off at the same time, indexing, coming in, and then machining the cut. And you'll see how what's happening there is it's superimposing the z-axis needed for the drill, but the end mill is taking precedence over that z-axis. I'm going to go in and I'm going to go ahead and do another pickup to move the chuck up to here after I have done this first operation on this side. So before I get ready to do these cuts here, I'm going to have it do another pickup. So let's add that pickup real quick. We'll go to machining, solid turn, and I'll do another pickup with the sub spindle. So the same settings here. Only difference is we're going to change this value to 3.75 and OK. And sequentially, I want that to happen after the back turn is done. So I'm going to drag this down, put it here. All right. So make sure that's there, and I'll drag this below there. Now, let's see. Oh, I think I got these backwards. I meant for this to be 231. I'm going to change that to 231, and we'll turn it off with a 230. And I'll do the same thing here. I'm going to do a 221 to turn this on. And I'm going to, right here, place a 220 to turn off the synchronous turning. So now we're not going to do synchronous turning to do our pickup. But once we do the pickup, we're going to turn it back on. Again, your machine may not require this, but it's important for you to know how to do these sync strings for those types of unique instances of how you need to control your syncs and to do other auxiliary things, like in this case turning on and off synchronous turning using both spindles. Okay, now, so once we're to this point, let's run another simulation, refresh our memory. Do the holes, drill, come in. Okay, it's going to come up and grab the first pickup. There it is. And now it's holding it at 2 inches. Now after this turns around and does the back turn, like so, we're going to now come back in and do another regrip against that shoulder. So we're grabbing as far as we can with that tool. All right, good.